Let's look at problem 990, Satisfiability of Equality Equations. For this problem, the typical methods to solve are breadth first search method and unifind method. Here, we are going to demonstrate the use of unifind for this problem. First, we are going to look at the statement of the problem, and then we go over the method and the main idea. And lastly, we give an implementation and explain some of the important points. First, let's look at the statement. So we are given an array of strings called equations that represent relationships between variables. So the equations can take two forms, either an equality relation or an inequality relation. So here the variables xi and yi are lowercase letters. So we are required to return true if these equations are consistent, otherwise return false. Let's look at the constraints of the problem. The constraints basically say that the equations as an array is not empty and its length is less or equal than 500, and each of the variables involved is a lowercase letter. So the problem statement also presents two examples. In example 1, the output is false because the two equations are inconsistent. And in example 2, the two equations are essentially the same equation. The return is true. So with the problem statement went over, let's look at the method and idea. So for this problem, we are going to demonstrate a unifind method here. The main idea is as follows. We are going to put all equal variables into one group and select a representation or root of that group. And then for the inequality relations, we are going to check the two variables involved, whether they have the same root. If they have the same root, then there is inconsistency, otherwise okay. So to fix the idea, let's look at one example which takes care of the generic case. So assume we have this array of equations. So from the first two string, we see A, B, and C are in the same group. So let's say they have a representation A. And also from the last two equations, we see E, F, G are in the same group. Let's assume they have a representation called E. Then if we continue add strings to the list, for example, A does not equal to C, then this will induce a inconsistency. The reason is that A and C are actually have the same root. So if we instead add A does not equal to E, this is okay because A and E have different roots and they are A and E respectively. So that's basically the idea and method we're going to implement in the following part. So before we do that, we also want to encourage you to look at Leetcode problem 2307. For that problem, we can implement a solution using either unifind or breadth first search. So it's good to have a try. So now let's look at the implementation here. So for clarity and for easily fixing the idea, I will split the implementation into different steps. First, we want to make some preparation. Here we want to remark that in order to implement union and find, so there are several different ways to initialize it. For example, using all lowercase English letters, or use those appeared in the equations. I will choose the latter. So for this, I will initialize three sets first. So one is a full set, one is equality set, one is inequality set. So initially empty, and then we're going to iterate from the equations. For this, I will just introduce two variables. So it's not necessary, but it it brings some convenience. So basically, for item in equations, I'm going to check the first index character. In other words, I want to check this one. So whether it's equality or not. If it's equality, basically we can track AB like this. Items, we use split method. We split at the equality relation. And then we can add this AB as a tuple to the equals relation. So we add this here. And otherwise, we split the item at not equal symbol, and then we add this to inequality relation. So, and in both cases, we are going to update the full set like this. So the purpose of the full set is get all the characters, unique characters involved in the equations. So once this is done, we are going to implement the union find hyperfunction. So for this, I'll first initialize a roots directory. So this roots basically store pairs of character and its parent. So for character in the full set, we get in the above iteration. So now let's look at the implementation of find method here. So it involves one character in the signature. So for this, we're going to make a recursion implementation. So this is very routine and short. So first we check if character equals roots character. So in other words, we check if character and its father are the same. If so, we return character. Otherwise, we are going to make a recursion call and apply to roots character. So this is the implementation for the find method. Notice that here we didn't use path compression. The reason is that for the problem here, so the vanilla find will be sufficient. So now let's look at the union method. So it involves two arguments, character 1 and character 2. For this, we first check their root. So find character 1 and find character 2. So if R1 does not equal R2, then we need to just union them together by setting the roots, say R2 equals R1. Or you can do roots R1 equals R2. Both are okay here. Here again, we emphasize that we didn't use the union by rank operation here, still because the vanilla union will be sufficient for us. So that's it about the union method. Third step is the actual work. So the actual work, in view of the idea, is simple now. First, we are going to do union operations for equality relations. And after that, we are going to check if the variables involved in the inequality relations have the same root. If so, there is inconsistency. Otherwise, it's okay. So first, we do the union operation for A, B in equals. So we just union them. And then we just check for inequalities. Here we want to check if their roots are the same or not by calling the find method. So we're going to, if they are not equal, if they are equal, we're going to return false because there are inconsistencies. After the loop, if there's nothing returned, we are going to return true. So that's a simple implementation of this union find solution. Let's check the special cases. Yeah, it passes the example 1. Let's modify this to example 2. We should return true in this case. So now let's look at this example. This should return true. This is as expected. Now let's add another one to return a false. Let's say A does not equals C. This introduces inconsistency. So let's check that. Let's check another one. Let's check A does not equals E. So this should return true as expected. Alright, so for this one, actually up to now we have given a solution. Let's check the generic case. It passes the generic case. Now let's also do some further work. Let's print the groups, right? So for this, I'll define a get components method. So initialize a dictionary. So we just iterate for key value in roots items. So if first I want to find the root for v, find v, and then we check if root not in D. We're going to set the root with a set with the current key. Otherwise, we're going to update the corresponding set by adding the current key, right? Then we return D. So for this example, let's print out the components. So we see that we have E, F, G, which is in the same group, and they have a root called E. And also A, B, C are in the same group, and they have a root called A, right? That's about it. Let's run it again. Oh yeah, so it passes the general case. So finally, maybe we make some remark about this further solution. So in this example, the group actually corresponding to the connected component if we use graph language, and also this A and E corresponding to the color if we want to solve this problem by coloring the different classes. That's about it. Thank you very much.